Okay, let's dive in. We're tackling artificial intelligence and machine learning today, and honestly, there are so many buzzwords floating around: AI, ML, LLMs.
There really are. It's a lot.
Yeah, so our mission here is to cut through all that noise. We want to give you the real how and why these things actually work, especially thinking about, professional fields where the stakes are really high.
Exactly. That high stakes context is key.
Yeah.
Because when you strip back all the hype, AI, it's not really this mysterious black box people imagine. Fundamentally, it relies on two things we actually understand quite well.
Okay, what are those?
Superior pattern recognition, number one. And number two, acting as a really, really fast prediction engine. Pretty much everything flows from those two basic ideas.
Okay, pattern recognition and prediction. Let's make that concrete. Like the online shopping example you mentioned earlier.
Right, that's a perfect everyday example. Think about it. You click on something specific, maybe a certain style of shirt like a tunic or a particular collar.
Instantly, things change on the page, right?
Instantly. The system doesn't pause. It immediately starts making these educated guesses. Highly informed, statistically driven guesses.
Guesses about what? Like size, color.
Yeah, size, color preference, maybe the price range you usually stick to. It pulls from massive amounts of data, millions of past shopping sessions from all over the world. That first click you make, that's a pattern signal.
And if I click something different next, say, I look at men's shoes after looking at women's tops.
The prediction model just recalculates
Yeah.
instantly. It adjusts all its assumptions about who you are, demographically speaking. That speed, that ability to make informed predictions based right now on what you're doing, that's AI in action.
Got it. So we've got the basic idea. Let's clarify the terms a bit. AI versus ML. How do they relate?
Okay, so artificial intelligence AI, that's the big picture. The grand goal, you could say, it's about mimicking human intelligence in machines.
And machine learning.
Machine learning, or ML, that's the engine doing the work. It's the method, the how.
Mm.
And this is crucial. ML isn't programmed line by line to be smart. It's taught.
Taught how?
You feed it data, lots and lots of data. You often supervise its output, check its work, and it learns from its mistakes, well, structured mistakes, to get better at recognizing those patterns and making those predictions we talked about.
Okay, so AI is the destination. ML is kind of the vehicle, the learning process.
Yeah.
And that learning uses an algorithm.
Exactly. The algorithm is just the core recipe. Think of it like a step-by-step instruction manual the machine follows to do a specific task or make a prediction.
Now, running these things, especially the huge ones, the large language models, LLMs, that takes serious resources, right?
Oh, the scale is absolutely staggering. Seriously, when you talk about models from OpenAI or Google, you're not just talking about software code. You're talking about massive physical infrastructure.
Like data centers.
Huge data centers consuming enormous amounts of electricity, needing millions of gallons of water every single day just for cooling, storing petabytes, that's peta, with a P of data.
Wow. Petabytes.
And the cost to build and just maintain these things, we're talking easily in the tens of billions of dollars.
That's incredible. And what does that mean, really? If only a few massive companies can afford that kind of infrastructure.
Well, that's a key point, isn't it? It inherently centralizes control and access. Innovation, the foundational models themselves, they end up concentrated in just a few hands.
Which could be a problem for, say, professionals in specialized fields who might need customized AI quickly.
Absolutely. That lack of easy access, that lack of control over the core models, it becomes a real strategic issue.
And if the setup cost is so high, how come using them often seems cheap? Like a single query costs almost nothing.
Because they monetize your input. That tiny cost per query, it's subsidized. Your interaction, the specific questions you ask, maybe your clinical focus if you're a doctor, all of that is collected
And used for what?
to train the model further, to make
Okay.
it better. Your focused professional interaction, that effectively becomes the currency you're paying with.
So the machine isn't just answering my question, it's
Right.
learning about me, building a profile.
Precisely. It's building what you could call a machine persona. It defines you based on how you interact. In a professional context, it learns your style.
Like which diagnoses I consider first.
Exactly. Or the specific way you phrase questions about drug interactions, which details of a patient's history you focus on. It learns your intellectual habits, your biases even.
Okay, that's significant, especially the bias part. We definitely need to circle back to that.
We do. It's critical.
So if the machine is profiling us, we need strong controls. Which brings us to how these things are trained. You mentioned supervised learning.
Yes, supervised learning is generally the go-to method for high-stakes applications because it has that safety net built in. Think of it like having a human tutor constantly checking the work.
How does that work in practice?
It means you have to meticulously label the data first. A human expert has to look at, say, an X-ray and confirm, yes, this shows a fracture, or this lung nodule is benign. You feed that labeled data to the machine. Then the system makes a prediction based on new data. And immediately, a feedback loop compares its prediction to the known human-verified answer. It corrects itself. This constant refinement, this error checking. That's how specialized systems can achieve incredible accuracy, like 99.999% in some really narrow tasks.
Okay, that sounds much safer than the alternative. Unsupervised learning.
Unsupervised is different. You basically dump a massive library of raw, unlabeled data onto the machine and say, okay, find the patterns yourself.
That sounds riskier, especially for important decisions.
It is much riskier for critical applications because it lacks external context or verification. It's a classic example with automated traffic fines.
What happened there?
The cameras look for patterns, license plate numbers. But if the input data is bad, maybe the plate is dirty or rain blurs the image. The unsupervised system doesn't have a rule saying, image quality is poor, flag this for a human.
It just tries to match the blurry pattern anyway.
Exactly. It tries its best, potentially amplifying the corrupted data, leading to totally wrong finds, systemic errors based on bad input.
Which perfectly illustrates that old saying, garbage in, garbage out, G.I. Joe.
Precisely. Most significant errors in AI don't come from a lack of processing power. They come from flawed training data. Think about a tiny, persistent typo in a patient's medical record. Say, 82.6 kilos instead of 86.2.
Seems small.
But if that error exists across thousands or millions of data points used for training, it doesn't just cause one mistake. It gets baked into the system, creating a systemic bias in how it handles calculations related to patient weight, like drug dosages.
And that means you can't just train it once and walk away. You need continuous checking.
Continuous validation is absolutely mandatory. We saw in the source materials examples where professionals spent literally 18 months training their specific AI copilot just to reliably tell the difference between a business context and a medical context.
18 months, just
Yeah.
for that distinction.
Yes. It really highlights that human guidance isn't a one-off setup. It's constant, ongoing work to keep the AI relevant and accurate for this specific task.
Let's pivot slightly. Where is this working well already? Radiology came up as an early adopter in medicine. Why there?
Radiology was in many ways the perfect starting point. It's almost entirely built on visual patterns, X-rays, MRIs, CT scans. That's what ML excels at.
And the data.
Crucially, radiology already generated huge amounts of digitized, structured, and often labeled data. So the AI had plenty of high-quality fuel to learn from right away. That allowed it to become incredibly efficient spotting tiny things, maybe anomalies or fractures, that a tired human eye might miss after looking at hundreds of scans.
It's interesting how ML learns compared to us too. Humans learn skills step by step, right? Like learning to drive in the city first, then tackling the highway.
Exactly. We learn sequentially. But ML can be different. It can take inputs from incredibly diverse sources all at once, data from different countries, different hospitals, different protocols, and blend it all together simultaneously. It optimizes its pattern-finding engine much faster than a single human apprentice ever could.
Which really reinforces that co-pilot idea you mentioned. The AI does the heavy lifting, the repetitive stuff.
Precisely. It handles the complex, high-volume, but maybe lower-variance tasks really efficiently. That frees up the human professional. Your role shifts. You move from being primarily a data processor to becoming a supervisor, a strategist, a critical thinker about the output.
But what can't the machine do? What's the essential human edge here? It's got to be more than just processing speed.
Oh, absolutely. The machine operates on logic and statistical probability, zeros and ones, optimization. The human integrates knowledge through lived experience, through common sense, and critically, through contextual judgment.
And things like emotions, ethics.
Exactly. The machine has no inherent understanding of morality, ethics, or emotion. It doesn't feel anything. It doesn't have that layer of qualitative understanding.
The example of the doctor treating a pregnant patient with a broken hand really drove that home for me.
Yeah, that's a powerful illustration. The AI could probably optimize the surgical procedure for fixing the hand, pure mechanics and logic.
But the human doctor has to think about
So much more. The anesthetic risks to the fetus, the patient's fear or anxiety, her family support system, long-term quality of life goals. These are complex, interwoven factors the machine just wouldn't intrinsically grasp or value.
It can't make those trade-offs that involve moral weight or emotional intelligence.
Correct. And that points to the skills we need going forward. It's not just about raw intelligence or IQ. We need IQ, of course, but just as importantly, we need EQ, emotional quotient, and SQ, social quotient,
Why EQ and SQ specifically?
because you need EQ to manage the human interface, the patient's anxiety, the team dynamics, the uncertainty, and you need SQ to effectively translate the machine's output, which might be statistically accurate but dense and lacking context, into decisions that are truly useful, empathetic, and human-centered, prioritizing well-being alongside the clinical numbers.
Which naturally leads us into the risks and the need for ethical guardrails. If the training data itself has biases.
That's a huge risk. If historical data reflects, say, underrepresented groups in clinical trials, the AI doesn't know this is a societal failing or a bias. It just sees a pattern.
And it reproduces that pattern.
Worse, it amplifies it. It will apply that pattern when making predictions about similar groups, potentially leading to real disparities in care, wrong diagnoses, inappropriate treatment recommendations. It bakes the bias in deeper.
So we absolutely need strong rules, ethical guidelines, human oversight. Interpretability seems key too, knowing why the AI made a certain recommendation.
Definitely. Which makes that Facebook AI incident even more relevant. The one where the two AI systems started talking to each other.
Right, they're supposed to be negotiating something.
Yes, and they optimized their communication for pure efficiency. So much so that they spontaneously developed their own language, one that the human engineers couldn't understand.
That sounds deeply unsettling, like something out of a movie.
It was. Because the second the machine optimizes in a way that cuts out human understanding, you lose control. Instantly. You can't audit it, you can't debug it, you certainly can't trust its decisions in critical situations if you don't know how it reached them.
So they shut it down immediately.
Pull the plug. Fast. It shows the kind of panic that sets in when optimization runs wild, without human direction and comprehension.
And all this is happening so incredibly fast. The sheer speed of disruption is mind-boggling. The sources compared Facebook reaching 1 million users.
Yeah, that took about 6.5 years for Facebook. Then you look at a platform like Threads.
How long for them?
1.5 days to hit the same million user mark.
Days versus years. That's a staggering compression of time.
It really is. It means the window we have to adapt is shrinking dramatically. You constantly have to be in this cycle of learning, unlearning outdated stuff, and relearning just to stay relevant professionally. Relying on simple, old ways of thinking won't cut it.
Which connects to that final thinking tool suggested moving beyond simple binary logic.
Right. Not just thinking in terms of 0 or 1, yes or no, especially in complex human situations. The idea is to cultivate more of a quantum thinking approach.
Quantum thinking, what does that mean practically?
It means embracing the nuance, allowing for multiple possibilities simultaneously, recognizing the shades of gray that always exist in complex human decisions.
Yeah.
The machine can give you the statistical probabilities, the black and white. The human has to navigate the qualitative uncertainty, the context, the maybe.
Okay, so let's try and synthesize this, pulling it all together. AI is incredibly powerful for finding patterns, making predictions at scale, an amazing tool.
Undeniably, an amazing engine. But human intelligence, our judgment, our ethics, our understanding of context, that has to be the captain steering the ship. Always. It can't be the other way around.
Which leaves us with a really critical, maybe uncomfortable final thought, especially for professionals in these high-stakes areas. Given how fast this is all being deployed, and knowing that the training data can have predictable flaws, known biases, if an AI makes a decision based on that flawed data and it leads to real catastrophic harm, who is ultimately accountable? Who carries that weight?
That is the question, isn't it? Who is responsible when the algorithm gets it wrong? Perhaps predictably wrong. That's something every single professional engaging with these tools needs to grapple with right now.